Okay, so we got a question right here. In 1995, the sixth quark, known as the top quark, was discovered using the Tevatron collider at Fermilab. A collision of a proton with an antiproton produced the top quark and a top antiquark. Particles may direct beam of particles at stationary targets or collide beams of particles traveling in the opposite direction. Explain the advantage of colliding beams of particles, right? So you have been given two scenarios. You can either explain two of these scenarios, basically advantages, right? So the first scenario is basically that you have, that I'm gonna write, is basically direct beam of particle, right, at stationary targets, right? Or it says they're both basically moving, right? Collide beams of particles traveling in opposite direction. Opposite direction, right? Opposite direction. So either the one particle is stationary and the other one collides with the stationary particle, or it's like the both are moving and they in opposite direction they both collide, right? So you can describe any one of these scenario and you can explain the advantage over there. So if I say about the first scenario, so if the target is stationary during the collision, right? So there will be of course a resultant momentum, right? Because as we know there's a collision happen, right? So there will be a resultant momentum. So basically the product that is made, before it was one is stationary and one is coming to collide them, so the resultant will basically have some kind of momentum, right? But as then also the product will also have the momentum, because it will create product once it collides with a stationary particle. A high beam basically collides with a stationary particle, it will of course make some products, right? So therefore it will have higher kinetic energy, right? So then if they have higher kinetic energy at the point where they collide, right? They collide over here, for example, right? And they will have some kind of momentum, right? Which will cause over here a higher kinetic energy, right? Therefore less energy when they will split up into different particles, right? They will basically have less energy while formation of these particles, right? So basically you will have small, this is a big particle, right? You will have these small particles, these small little particles being formed, right? You don't have basically a large massive particle being formed, right? If you try to explain the second one, right? So one is coming from here and the other one is coming from here, right? They both collide at this point, right? So it will be the opposite of what is happening in here, right? So it will basically have zero momentum, right? Why? Because they are coming in opposite direction, right? In before momentum they're coming in opposite direction, right? They're canceling each other out, right? So that's why they will have zero momentum. So basically the product after the collision basically will have, basically will not have high kinetic energy as was having before, because before only one was stationary and other was coming at really high speed, right? So we know there will be some kind of momentum, right? Before, as we know, m1u1 plus m1u1 plus m2u2 is equals to m1v1 plus m2v2, right? We know only this thing will be only zero, right? Because this is the mass of the second stationary particle, so only this thing is going to be zero. This thing will have some kind of value, right? So that's why we have in resultant, there's like basically we have in resultant the high energy as well, and its momentum is also there, right, in the resultant product, right? That's why when it has in the resultant product the higher kinetic energy, they will form less particle, because they're splitting up these, splitting up into small particles as I have shown here. While what's in here, they both cancel out each other, right? So basically they won't have any momentum at before, because they have to, if they're canceling out each other, right? So basically their after momentum has to be also zero, which means they won't have not zero, but it should be very less, they might not fully cancel out. I don't know if they're canceling out fully or not, because I don't know what is their energy, what is their speed, at what speed they're colliding, right? So I can basically say they might be close to canceling out, right? So I can say they have very less kinetic energy, because now they're basically closest to zero, right? This is not closest to zero basically, because this have like a high value as well, right? So we can say that if they have less kinetic energy, so they can provide more energy to the particles that had been made from it, the scattering particles, right? So basically once they collide, they make large or massive particles, right? So make bigger particles, because of the so much energy is being like concentrated at one point, right? So not the kinetic energy, but just the overall energy available for this product to be made, right? So yeah, this is, so let me write out this sentence for you guys as well for the both situations. Okay, so I have written the sentence for you guys. This is the first scenario sentence. If the target is stationary during the collision, there will be a resultant momentum, which means they will have high kinetic energy. Therefore, less little energy available for the formation of particles, so less massive particles are formed. If you still didn't get what I was trying to say, you can use the formula m1, basically m1 v1 m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2, right? This is final, this is initial, use initial, right? So basically you can just compare it through this, and then the kinetic energy formula, right? 1 by 2 m v square, right, as well, v square, yep. So you can compare it as well from here, right? If this target is stationary, as I know, this will become 0, this m2 u2 will become 0, because the initial velocity of this is basically 0, the other momentum is basically having a 0, right? So this will, if, because now only this momentum is before, as we know, conservation of momentum, both momentum before and after has to be same, except until if there is basically any external force being acted, otherwise they always basically they have same momentum, right? So if this is 0 and this has some high momentum, this means the after momentum will be higher as well, right? And as we can see, it's, there's no big change over here, right? They're basically having the same formula, you're just changing the speed. If the speed is higher, the kinetic energy will be higher as well, right? So means that most of the energy is basically being taken by the momentum, by the basically by the collision only. And if you, for example, you have basically 5 energy, right? And during this collision, your total, this is 5, right? And during this collision, and your resultant momentum basically takes 4 energy, because it's a high kinetic energy, so it's basically taking like the most amount of energy from it, right? So it's taking 4 energy, right? So you're left with basically how much? You're left with basically 1 energy, right? To basically give the formation of particles. Just think like that, right? And in this thing, if these two basically are colliding in different direction, then this positive sign will become negative sign. Why? Because as we know, velocities the velocities are vector quantity, right? So their direction matters, right? So if they are going in opposite direction, because then this will have negative sign, right? So they can basically, if they're going in a equal speed, right? So they both can have either 0 or they have less momentum, right? So if they have less momentum, for example, you have again the 5 energy, right? And they both collide, and they are basically they have less momentum over here, right? Which means they will have less kinetic energy, right? As well, because they're both the same thing, right? So if they have high momentum, they have high kinetic energy. If they have low momentum, they have low kinetic energy, or basically no kinetic energy at all, right? Less kinetic energy is the most suitable word. They do not have high kinetic energy, right? So means if you use like basically one very less kinetic energy, right? So you give most of your energy to basically the particles, right? So there are more energy available, or all energy available to the formation of particles. So that's why you have massive particles formed, right? You can think it this way, right? It is much easier to think using the formula and basically the simple concepts, right? So this is your final answer, and this is an example sentence. You can write it in your own words.